alive makes for an awkward conversation. They demur, they stammer, they offer a flimsy notion that crumbles under scrutiny. Is this something they just don't want to talk about, or is it something they're embarrassed that we don't know?
I honestly just think it's something that biologists are not trained to
Maybe
really
ask
think about that
what
much.
the nature of definition is.
As a biologist, you're trained to get answers about life. And
is.
so, you might be very interested in maple trees. And so you want to understand, how do maple trees reproduce? And you drill down and down and down into the molecular details of that, and you publish paper after paper after paper. There's much less of an incentive in biology to step back and be like, okay, like what does all this have in common? What does it mean for all these things that we call alive?
And that's the nature of definition.
So there are people who
exciting
dare to tread on that very dangerous territory, but not a lot.
Along with the history, you go through.
Tread there, buddies.
This book traces your adventures through a lot of different labs, environments where you look at creatures and experiments that complicate our understanding of what is alive and what isn't. And it struck me that throughout the book, you get to do science yourself.
Are viruses alive?
I was reading some of these things, saying, I wish I could do that stuff. Putting together experiments in lab with researchers, getting your hands dirty with kelp on the beach. Do you have a favorite experience of any of those that you've written about in the book?
It was a really wonderful experience to be able to visit with scientists, travel with scientists, in order to kind of explore the territory of life. And there were different hallmarks of life that everyone generally agrees on, and I wanted to kind of really get to know those hallmarks by looking at certain species that were really the exemplars of it. So, for example, life has a certain kind of intelligence, a lot of scientists would argue. In other words, living things make decisions about what to do based on their environment. So, we make decisions every day. What are we going to have for lunch? But I was really fascinated by scientists who study these things called slime molds, which are these bizarre science fiction-like creatures that live on the forest floor. They're everywhere. You go out in the summer and you'll see them if you know what to look for. And they send out their tentacles across the forest floor looking for bacteria to eat. And they have to decide where to go and basically how to lay out their network.
All that stuff is coordinated by signals between fungi and plants.
They are like little mathematicians making calculations on the most efficient way to cover a certain area and to find certain kinds of food. They can solve mazes. So I have to say that was a particularly fun experience.
The same thing if we work together.
Let's go into some more modern theories about life, because these are the kinds of things we cover all the time, and it's amazing how quickly the definitions change. I mean, you have a line in your book that I absolutely love. Let me quote it. We don't know when a theory of life may arrive, but we can hope that our own lives last long enough to let us see it. As longtime science journalists, we've both seen research on biology really accelerate. Do you think we'll get more insight into this in our lifetimes?
I do, actually. I mean, I think that there are a number of scientists, not just biologists, but physicists, for example, who are really working hard on developing a theory of matter that could explain life. And this would be in the same way that, chemists developed a theory of matter that explained, molecules and water and all the sort of inanimate substances around us. And so, you need theories to really, to get a deep understanding and to be able to understand even more. And those theories are in the works right now, and there are several different theories that are being developed, which are very exciting. I don't think anyone really pretends that they've got the definitive theory all worked out. But when you talk to people in this field, they sort of feel like, I think we're going to sort this out. They're pretty optimistic, which is nice. But it is a little frustrating that imagine
if you want to talk about matter,
living right before the theory of chemistry started to make molecules and atoms and elements make a lot more sense. That's kind of where we are now.
You mean agreeing all of us on what life is.
Yes, to have it.
So is it criteria? I mean, we're looking for it. We're going to other planets. Do we need a set of specs to understand? Hey, this is life.
Well, we. On the one hand, it would be nice to have a really clear theory of life before we go searching for it. But on the other hand, we don't want to wait forever. So NASA is using kind of working definitions of life to kind of get some clues. And so, honestly, like they're looking on Mars for rocks and other patterns that kind of look like signs of life on Earth, which is fine. But, what if life on Mars or on some moon around Saturn or in another solar system doesn't play by our rules, isn't based on DNA, doesn't even use carbon? Like, we need a deeper understanding of life to really be open to all the possibilities.
Open to the mountain.
Let's move on to talk about
you don't want that
cutting-edge research on synthetic organisms, because it really has moved very, very quickly.
Not so bad.
Just last month, there was news that scientists created a synthetic cell that grows and divides as normal. Other cells have been created with completely synthetic genomes. What do you think, Carl? Do these synthetics ride life's edge?
Why do you have a life's edge?
I think they do.
Why don't you just try to call it everything life?
In some cases, what we're looking at are examples where you're sort of taking life as we know it and sort of pulling pieces out of it and figuring out what's the bare minimum that you can get by, and this thing still operates in the same way that it did originally before you started pulling all the genes out. So there are other scientists who say, like, well, wait a minute, like life didn't start with, a complicated cell that got stuff pulled out. Probably what happened is that there were proto-cells that didn't even have DNA in them. They probably had a much simpler molecule, RNA. We have RNA in our cells. But some scientists think that inside of these proto-cells, the first cells on Earth, you would just have RNA that was carrying genetic information and carrying out chemical reactions. So they're trying to build these proto-cells as well. And that's, still got a ways to go before you have a really full-blown RNA protocell that can really just thrive and grow and do all the things on its own. But they are getting there. And so, again, I wouldn't be surprised if in 10 or 20 years we're looking at these things that could be a very good model for how life began.
Something new. That's not how it began.
But there are other people who are just saying, like, well, let's not fixate on RNA. What if we just look at different combinations of simple chemicals and see if they form droplets that show lifelike behavior? And that sounds crazy, but they're actually, at the University of Glasgow, they're actually making some strange droplets that skitter around in petri dishes that split in two. Kind of looks like they're reproducing. There's just some weird stuff happening there, and they're using robots to keep changing these recipes to see if they might just stumble across droplets that we might call alive.
Just a quick note that I'm Ira Plato, and this is Science Friday from WNYC Studios.
My guest is...
We're also making, as you point out in your book, little mini organs, body organs, that are not fully formed brains or lungs, but they are enough to work with.
Yeah, I mean, when we think about life, we often think about, when life begins. We think of that boundary in terms of the start of life, and that's very controversial when we think about human life in particular. Scientists are really complicating our efforts to kind of draw that line by being able to grow things from cells. So, for example, I went to a lab where they can take one of your skin cells and put it in a dish, hit it with some chemicals, and it basically turns into a neuron much like in a human embryo, which then will start to grow and divide into hundreds of thousands, millions of neurons that organize themselves on their own into a brain-like structure. And if you just keep giving it the right chemicals for food, you can keep it alive. I think we'd agree it's alive for years. So here's this thing that even seems to be producing brain waves, but it's not inside a human body. It started out as a skin cell. So, you know, is that alive? And, you know, how do we deal ethically with this life? We have no answers to these questions.
Ask why you
Well, what about the question about artificial intelligence? Do you think it would ever meet the criteria if we come up with some definition of life?
Yeah, you know, well, I mean, there's artificial intelligence, which, you know, is able to say, this image looks like a cat to me, but, you know, that might tick off some of the boxes that we have for what it means to be alive, but I suspect it wouldn't tick off other ones. It's not as if, you know, Google has artificial intelligence programs that are reproducing themselves, you know. So
you will soon.
If that's your standard for life, then I don't think that we consider it alive. But, you know, it's interesting that we might be able to just skip all that and all those criteria and have something we might agree is intelligent or even conscious, without all the other things that go with being alive.
Artificial stupidity.
Interesting stuff. There's so much to talk about, Carl, in this book. So much to contemplate. Thank you for taking time to be with us today.
Thank you. It's been a pleasure.
Carl Zimmer, science columnist for the New York Times and author of the book Life's Edge, The Search for What It Means to Be Alive.
Life's Edge.
One last thing before we go. If you like books, we hope you're reading along with our spring book club.
My book,
We're talking Lost Feast by Lenore Newman, a book about the extinction of food species, the current state of biodiversity, and what's next for agricultural systems. Plus, did sailors really turn the dodo into soup?
They were tough. They were fishy. There's actually documentation about how bad they were.
Join our next virtual discussion on Zoom. Find our online community forum or just sign up for our newsletter, all at sciencefriday.com/book club. If you missed any part of this program or you would like to hear it again, subscribe to our podcasts or ask your smart speaker to play Science Friday. We also had help this hour from Jay McAuliffe, who served as a sensitivity reader and consultant for our discussion of gender-affirming healthcare. Of course, you can always say hi to us on social media, Facebook, Twitter, Instagram, email. We're there all week. Have a great weekend. We'll see you next week. I'm Ira Flato.
Got a veteran. Thank you!
Science Friday is supported by Progressive Insurance, committed to providing